In this video, I'll demonstrate how to configure the Multiplex protocol in MyAssays Desktop for use with Luminex xPonent CSV data files. I'll start in the MyAssays Desktop Explorer, and on the Protocols tab, I'll select to open the Multiplex protocol. This protocol is included with your installation of MyAssays Desktop. If you plan to make changes and customize the protocol to fit your needs, it can be helpful to save a copy of the protocol under a different file name. This way, you can maintain the integrity of the original protocol for use in the future. The CSV Luminex xPonent data files are supported file types, so by using the import wizard, our data will be automatically formatted and imported. You can see that when we open the import wizard, we have the option to import various parameters, including measurements, dilution factors, sample IDs, and analytes. I'll leave measurements selected and press Next. Now we can browse for our desired measurement file and press Next. On this screen, we can see the data organized by analyte with a plate overlay. You can toggle between the different analytes by using this drop-down box. You can also view the data in a pad format, see any associated metadata, as well as view the source file. When we press Finish, if we leave this checkbox selected, the results will be calculated. However, I would like to import the data and take a look at some of the settings first, so I'll uncheck this box and press Finish. Now if we click on the Measurements tab, we can see that our measurement data has been imported, including the analyte names. We can visualize the data for each of the analytes by using this drop-down box. We can view the data in 2D or 3D, clicking and dragging to rotate the view. You can also view the data as a heat map, with green corresponding to lower results and red corresponding to higher results. On the Microplate tab, we can select from any of these available plate layouts, edit one of these layouts, or create your own. It's important to remember that you can edit the plate layout before or after importing your data. This can be useful if you find there's an error in sample preparation or if you're running partial plates. In this example, I've only run half a plate, so I can edit my plate layout and remove the unknowns on the second half of my plate. Once I'm satisfied with the layout, I can click Save and Close. On the Plate Dilution Factor tab, I can specify the plate dilution factor, and if I've not made a plate dilution, I'll leave this value set to 1. On the Sample Dilution Factors tab, we can add dilution factors that are specific to each unknown sample. You can use the Series button to automatically apply the dilution factors to our unknowns. You'll notice the visual feedback on the right-hand side of the screen. With the Series button selected, all of my unknowns flash. However, when we turn the series mode off, only the currently selected unknown flashes. To use the series mode, you can specify an operator and a factor. You can also use the repeat function, which will apply the specified series and repeat after the specified number of samples. So for example, we could set the dilution to multiply by 2 and repeat after 8 samples. And you can see the resulting dilutions are filled in for us. But in the case of my assay, unknowns 1 and 3 have been diluted 1 part sample to 1 part diluent. So I'll enter 2 for their dilution factors. The rest of my samples were run neat, so I'll leave their dilution factors set to 1. On the final tab, we can enter our sample IDs. We can manually type these in, copy and paste them in from the clipboard, or use the import wizard to import our sample IDs. I have a file containing the sample IDs for my assay, so I'll go ahead and open the import wizard. You'll notice the wizard defaults to sample IDs because we have the sample IDs tab open. I'll press Next, browse for my file, and press Next. Now we can see a preview of the sample IDs we've imported. Again, if we leave the Calculate Results checkbox selected, our results will be calculated, but I have a couple more settings I'd like to review, so I'll deselect this checkbox and press Finish. Under the Properties control, we can see more details about the calculations this protocol will perform. First, there's a standard curve fit transform. I'll cover some of these settings briefly, but for more detail about configuring this transform, please see the associated video. Under the Axes settings, you can define the axes titles and types. The Calibrators section allows you to specify the calibrator values for each analyte. If we click the drop-down box, we can see a list of the analytes on the left-hand side, the settings to apply in the middle, and a list of the calibrator values for the currently selected analyte on the right-hand side. With the series mode set, you can specify the starting concentration for each analyte, select an operator, and define a factor. The rest of the calibrators in the series are calculated automatically using these parameters. Alternatively, you can deselect the series button to turn the series mode off and manually enter or paste in your calibrator values. You can enter a unit to be applied to all analytes if you have the Units button selected, or deselect the Unit button to enter a unit for each analyte individually. I'll enter my starting concentration of 2000 for the RBP4 analyte, and the series is divided by 4. You can use the Chart section to add error bars or additional points to be plotted on the curve. And the Fit section will allow you to specify your fit method and any weighting model or transforms that should be applied. You can see that I've chosen to use the best fit method. This fit method compares various fit methods and weighting models and automatically applies the best fit. The best fit is determined by the fit score method, and in this case I've chosen R² with low end accuracy. The best fit is a great feature for multiplex assays because it will perform this comparison for each analyte, and if necessary, the software can apply a different fit method to each individual analyte. For more information on the best fit feature, please see the video on that topic. And finally, the quantification limits allow you to define the acceptable limits for accuracy and precision for your calibrators. After the standard curve fit calculates the concentrations of the samples in our assay, the factor and dilution factor transforms apply the plate dilution factor and the sample dilution factors. And finally, the percentage coefficient of variation transform calculates the percent CV of the replicates for each sample group using the concentration times dilution factor data matrix. You can use the other tabs in the Properties control to make changes to Matrices settings, add evaluations or validations, and configure your report format. Please see the additional videos on those topics for more information. Now let's calculate. On our report, you'll see it's separated into different tabs for each analyte. The first tab for each analyte is the sample table, detailing the concentration and percent CV results. On the second tab for each analyte, you'll see the curve and fit details. You can see the limits of quantification, as well as the limits of quantification times the plate dilution factor. The curve coefficients are listed, as well as the goodness measures. The calibrator chart shows the calibrators and all of their information, including their precision and accuracy. You'll remember under the standard curve fit transform, we specified the limits of quantification to be plus or minus 20%. Any calibrator with either precision or accuracy results that do not meet these requirements will be highlighted in light red, while those that do meet the requirements will be highlighted in light green. If you're using the Best Fit feature, you'll see a table that lists each of the fits compared, ranked in order of the fit score method that we chose. In this case, the 5PL 1/x² fit was determined to be the best and was applied to our data. At the top of our report, we can see tabs with each of the analyte names. If we click on these, we can see an interactive curve chart for each of the analytes. You can optionally exclude outliers by left-clicking on them or choose to save the curve to a library. So we've demonstrated how to import multiplex data from your Luminex xPonent reader into the multiplex protocol and how it can be configured. You can also fully automate your data analysis process by using folder poll in conjunction with MyAssays Desktop. MyAssays can be configured to automatically import, calculate, and export your data as soon as a new measurement file is detected. This topic is covered in more detail in a separate video. If you have any questions about working with Luminex xPonent data files and the Multiplex protocol, please email us at support@myassays.com.